The elimination method. To solve a linear system of two equations and two variables, perform the following steps. Step 1. Choose one of the two variables to eliminate. If necessary, multiply one or both equations by suitable constants so that the chosen variable has coefficients that are opposites. Add the two equations to eliminate the chosen variable from step 1 and solve the equation for the remaining variable. And finally, substitute the value from the variable in step 3 into either of the given equations and solve for the remaining variable. So basically what we want to do is we want to add the equations we were given together, but our goal is that when we add them, one of the sets of variables will add to 0. To make sure that will happen, sometimes you'll need to multiply your equations by constants so that the coefficients of the variable you want to eliminate will have opposites. So say, for example, 5 and negative 5. If you have an equation, let's just write using a bunch of letters, x plus y equals z, and you multiply both sides of the equation by the same number, this equation maintains its equality. So with knowing that, we're allowed to multiply both sides of our equations by constants without changing the equality. You may change the way the equation looks, but you don't change the solutions to the equations. So we can utilize that rule to write our equations in a way that allows us to eliminate some of our variables. And then we'll be left with an equation in just one variable that we can solve for, and then substitute that back into the beginning like we did with the substitution method to solve for the other variable. Let's look at this system. Now this system is already set up in standard form, meaning we have ax plus by equals c, which makes it very easy to start our addition. Also notice that our x's already have opposite coefficients. So if I just add these two equations together the way they're written right now, my x's will add to 0, my y's add to 1y, and negative 2 plus 4 gives me 2. And I do not need to have that coefficient of 1, so I've literally already solved for y. Y equals 2. Now what we can do is we can substitute this value for y back into one of the original equations. Let's say we take the top equation, and our new y value is 2. And this leaves us with an equation that only has an x that we need to solve for. And we get back x equals 2. So the solution to this system is the point 2, 2. Again, we can graph this to verify. And we do intersect at the point 2, 2. Exercise 5, again, we want to use the elimination method, but unlike in exercise 4, unfortunately, none of our coefficients on the matching variables are opposites. What that means is we're going to have to multiply our equations by some sort of constant to make those opposites happen. Now, our y values already have opposite signs, so you could choose that, but you can really choose either variable that you want to eliminate. Let's try to choose y though, just because they already have those opposite signs. So if I'm looking at the numbers 5 and 7, the least common multiple of 5 and 7 is 35. So what I'm going to do is I'm going to change these coefficients into negative 35 and positive 35. And I can do that by multiplying my top equation by 7, and you want to multiply both sides. So if we multiply this through, we get back the equation 21x minus 35y equals 77. And let's multiply the bottom equation by positive 5. Now, if you didn't have opposite signs, you would want to make sure that you multiply one by a positive number and one by a negative. When I distribute this 5, I get back the equation 20x plus 35y equals 5. So now I can kind of rewrite my system with the new representation of my equations. And notice I could add these together and my y's will cancel. So if I just remove that bracket I put in, and then let's add these straight down. So our x's are going to add to 41, the y's add to 0, and the constants at the end add to 82. Now we just divide both sides by 41, giving back that x is equal to 2. And like before, we just substitute this back into one of the original equations and we'll get y. So I'm going to plug it into the top equation. So I'm plugging in that x equals 2 and solving for y. And we get back y equals negative 1. So the solution to this system is the point 2, 1. Take a second and try the first part of problem 6 on your own. So solve this using whichever method you like. So when I look at problem 6, part 1, I see that the coefficients on my variables, at least my x's right now, are already opposites. So I think I'm going to use the elimination method. But to use the elimination method, remember you have to have your equations in standard form so that you can line up your equations when you add them. So I just need to rewrite the order of this bottom equation by adding the 2y over to the other side. And now let me rewrite that top equation above. And I'm going to add straight down. But when I add straight down, my x values add to 0, my y values add to 0, and my constants add to 0. So everything disappears. So hopefully when you tried this on your own, you found something similar to this where basically everything canceled out. If you get back a true statement like we just did, where 0 equals 0, we call this an identity. What this means is that the two lines that we were given, or these two equations, are equivalent. And no matter what value I plug in for x and y, if it lays on one of these lines, it's going to be on the other line, because the two lines are technically the same. The only thing that makes these lines different, let's look at the one that I crossed out earlier. If I multiplied that top line by -1, which we saw earlier doesn't change the equality, I get back the exact same line I had for number 2. So these two lines are the exact same line. Think back to the picture we had. If we have the exact same line, the lines are overlapping. This is a consistent system where every point on the overlapping line represents a solution, or in other words, we have infinitely many solutions. Take a second and try part 2, and then take a guess at what you think the answer may be. Come back and check your work. This time, both of our variables canceled out, but the result we got was that 0 equals 4, which is a contradiction. So if you do your work and your variables cancel out and you get back something false, what this implies is that there are no solutions. And if you think back to the lines we had when we had the picture, the case that has no solutions is when we have parallel lines, meaning that our lines never intersect each other. And notice, if I write both of these as y equals mx plus b, so the top one I'm just writing with the y on the other side. The bottom one, if I solve for y, I'm going to add x to the other side. These two lines do have the exact same slope of positive 1, but they have different y-intercepts. So these two lines are not the same, but rather these two lines are parallel. So they're never going to intersect, which means there will be no solutions to this system. Exercise 7. The volume of the cylinder is V of R and H equals pi r squared h, and the lateral surface area of a cylindrical container is S of R and H is 2 pi RH. R stands for the radius and H stands for the height. So if we had a cylindrical container, just to give you a visual, the top here is technically a circle, so if you were to look down on it, there would be a radius, and this container has a height of h. So those are what our variables are referring to. We want to write a system of equations whose solution is the dimensions for the cylinder with volume of 40 pi inches cubed. Write a system of equations whose solution is the dimensions for a cylinder with the volume of 40 pi cubic inches and a lateral surface area of 60 pi square inches, and then solve the system. Okay, well the volume is V, and the equation for volume is pi r squared h. And here we're told that our volume is 40 pi. So all we need to do is to replace V of R and H with 40 pi. The surface area is 60 pi, and the surface area is S. So now we need to replace S of R and H with 60 pi. So here's our system. Now this one's a little bit different than the last few we did because we're not just dealing with. Now this one's a little different than the ones we've been doing where we had like nice lines, but you can still solve for one of the variables and then substitute it back into a different equation. So take a second and try this on your own. It may be a little frustrating at first, but give yourself time to think. Pause the video, try to solve one of these equations for either R or H, and then substitute it back into the other equation and solve for one of your variables. Remember that pi is a number, so don't solve for pi, but either solve for r or solve for h. Pause the video, give yourself some time, try it out, and then come back and check your work with me. Okay, when I look at my two choices, I tend to gravitate toward the blue equation because there's no exponents. So I'm going to take the bottom equation and solve for one of my variables. Maybe I'll solve for r. So what I need to do is I basically need to divide away everything but r since these are being multiplied. So all of these will simplify on the right. On the left, the pi's will simplify, which is nice, and the 60 and the 2 will go into a 30. So now I have just 30 in the numerator over h in the denominator equals r. So now I have solved for r in terms of h. Let's substitute this into our green equation. Our new r is 30 over h. Oops. Our new r is 30 over h. And this quantity is squared. All right, so I have 40 pi equals pi times 30 squared, which is 900, over h squared times h. The h's will simplify, so I have one h on the top and one on the bottom, which just, I'm sorry, 2 on the bottom, which just leaves 1 in the denominator. I can also divide away that pi to the other side. Leaving 40 equals 900 over h. And we want to solve for h, so I need to get h out of the denominator. So let's multiply both sides of the equation by h, which will get rid of it in the denominator. And now I can divide that 40 over to the other side. Simplifying this fraction, I get 45 over 2. We just need to plug this back in to our equation for r. So 30 over our h, which is 45 over 2. Okay, well this is the same as 30 times 2 over 45, so when you divide by a fraction, you multiply by the reciprocal. That's 60 over 45. Remember, this is all equal to r. Dividing top and bottom by 15, I get 4 over 3. So what we found is that our radius is equal to 4/3 inches, and our height is equal to 45 over 2 inches. Or if you wanted these as decimals, your radius is about 1.33 and your height is 22.5.